Hey guys, welcome to another video. Today we're going to be continuing our quick revision. Today we're going to focus on Unit 7, which is differential equations. So we are going to do like two, two questions about it. The first question is very straight to the point. The second question is considered to be depth of knowledge 3, DOK 3, because it has like these four subparts. And it is DOK3 because you have to use like prior knowledge taken in AP calculus. So for the first question, they told us to solve the following differential equation. dy over dx is equal to 6x cubed square root of y, given y is equal to 0 and x is equal to 1. Give your answer in the form of y equals f of x. So whenever they give us a question like this to solve a differential equations, you have to understand that you have to group up together the y, everything that related to y with dy, and you have to group up everything related to x with dx. So what I'm going to do over here, I am going to cross multiply, selective cross multiply. And the meaning of the word selective cross multiply is basically I'm going to choose to multiply the dx with 6x cubed, and I'm going to drop down the square root of y down. So what's going to happen is basically this is going to be dy over the square root of y equals 6x cubed multiplying the x on top. So this is dx. So all I did was basically switch up the positions of square root of y and dx, and then you have every single right to do so because this comes from the rule of cross multiplication. And it is selective cross multiplication because I chose to only use square root of y in my multiplication. I didn't choose to move 6x cubed whatsoever. Now, we are going to plant an integration symbol over here. We're going to plant an integration symbol over here. So fairly speaking, the integration for 6x cubed is fairly simple. It is 6x to the power of 4 over 4. Now the integration for dy over the square root of y, instead of the square root of y, I'm going to change it to y to the power of half. And then when you transition y to the power of half from the denominator to the numerator, it is going to look like y to the power of negative half dy. So the integration for this, we're going to add 1 to the power, and we're going to divide it by the new power. So it's going to be y to the power of half divided by 1 over 2, which is equivalent to saying 2y to the power of half, because everything divided by half is the same as multiplying by 2. So this is 2 square root of y. And as we were saying before, that the integration of 6x cubed is going to be 6x to the power of 4 over 4 plus c. So all in all, the first integration is going to be 2 square root of y, as we said. And the second one is going to be 6x to the power of 4 over 4 plus c. Now, we want to find c, and then we have to give our answer in the form of y equals f of x. So let's find c first. So this is our equation over here, right? So this is our main equation that we're working on. Let's write it down again over here. 2 square root of y equals 6x to the power of 4 over 4 plus c. The initial conditions that they gave me, they said that y is equal to 0 and x is equal to 1. So you're going to replace y with equal to 0 and x is equal to 1. So you're going to get 2 multiplied by 0, or like square root of 0, which is literally the same thing. X is going to be replaced with 1, so it's going to be 6 over 4 plus c, which is going to give me 0 equals to 6 over 4 plus c. Move the 6 over 4 to that side, so it's going to be negative 3 over 2, with simplification, of course. So this is my c. So now, finally, the final expression is going to be 2 square root of y equals 6x to the power of 4 over 4 minus 3 over 2. Now, since they want us to write the expression in the equation in terms of y equals f of x, that means I have to isolate 2 square root of y. I need only y in my equation. So I'm going to divide by 2 over here, and I'm going to divide all of this by 2. So then you're going to get square root of y equals. So over here, like all of this divided by 2, we're just going to multiply the 4 by the 2. So it's going to be 6x to the power of 4 over 8 minus, and then you're going to multiply over here the 2 by the 2. So it's going to be negative 3 over 4. Final step, you just raise everything to the power of 2. So square root of y, raise it to the power of 2. So it's going to be y equals 6x 4 over 8 minus 3 over 4 to the power of 2. This is more than enough. You don't need to expand the whole equation to get it. So this is our y equals f of x equation. Now, DOK3. We got, consider dy over dx is equal to 3 minus 2y. Let y equals f of x be the particular solution to the differential equation with f of 2 equals to 1. So over here, when they say f of 2 is equal to 1, they're basically telling me that the initial condition, when x is equal to 2, the y is equal to 1. So this is basically what they mean with this initial condition. But all they're trying to do is try to trick me, because it's literally the same exact thing as we did over here. I could literally tell you, instead of this initial condition over here, I could tell you that f of 1 is equal to 0. So this is what they mean. In part A, they said write an equation of the line tangent to the graph of y is equal to f of x at x is equal to 2. Use the equation to approximate f of 2.6. Now, you probably forgot about this, but back in Unit 5, when they always used to ask me about the tangent to the function, whatever, etc., etc., the equation for the tangent, it was usually y minus the y at that certain point equals y prime at that certain point, x minus x at that certain point. So we're going to translate this into the differential equations that we have over here. So what we're going to get is basically the y of the tangent, in this case, minus. They said that x is equal to 2. So y of 2, all right, equals y prime, which is going to be our dy over dx. So it's going to be dy over dx at that point 2. At the point 2. And then x minus at that point 2. So now, the y of the tangent minus, what is y of 2? I already have it. When f of 2 is equal to 1, that means y of 2 is equal to 1. When x is equal to 2, y is equal to 1. So it's going to be 1 over here equals dy over dx when x is equal to 2. I know that when x is equal to 2, y is equal to 1. So I'm going to replace y is equal to 1 over here. So 3 minus 2, it's going to be 1. And then x minus 2. So the equation of the tangent is going to be y of t equals, so 1 times x is x, 1 times negative 2 is negative 2. So it's going to be x negative 2. And then you change the minus 1 over here, so it becomes positive 1. So x minus 2 positive 1, which is going to be x minus 1. And that is going to be your equation of the tangent. Now, they said use this equation, the tangent equation, to approximate f of 2.6. So y of 2.6, it is going to be 2.6 minus 1, which is going to be 1.6. That's it. So just to summarize all we did in this question over here, what we did in this question over here is basically find the equation of the tangent. And how do we find this equation of the tangent? By using the same equation we were using all time long in unit 5. This one over here. So hold on, let me just, okay. So y minus y of a is equal to y prime of a, x minus x of a. Now remember, a in this case, this is just the general formula, obviously. A in this case is the x that they gave it to us, which in this case, they imply x is equal to 2. All right, and we know that when x is equal to 2, we know that y is equal to 1 in this case. So this is how like our solution came to be. Even if you don't have like x in this expression, I do have a y. And I do know that when x is equal to 2, y is equal to 1. Now, part B. Find the value of d squared y over dx squared at 2, 1. Is the graph concave up or concave down? So let's remind ourselves that, again, this is a DOK3 question, so of course it's going to require prior knowledge. Now, if d squared y over dx squared, it is positive, so is positive, that means it is concave up. And if d squared y over dx squared is negative, concave down. So now I know that dy over dx is equal to 3 minus 2y, correct? So d squared y over dx squared, the derivative of 3 minus 2y, it is going to be minus 2 dy over dx. And now what is dy over dx again? So it is going to come back to this. So once again, the derivative of 3 is going to be 0, obviously. And the derivative of minus 2y is going to be minus 2 dy over dx. So it's going to be minus 2. And then dy over dx is again 3 minus 2y, which is going to be minus 6 plus 4y squared. Now let's find the value at the point 2, 1. Now, do we have an x? Nope, we do not, but we have a y. So d squared y over dx squared, we're going to replace the y with 1. So minus 6 plus 4, 1 to the power of 2, it is going to be minus 6 plus 4, which is negative 2, which is negative. So is it concave up or concave down? It's going to be concave down. And that's it. Moving on to part C. They said, find y is equal to f of x, the particular solution for the differential equation given f of 2 is equal to 1. This is going to be the same exact thing as we did in the first exercise. So we're going to say that dy over dx is equal to 3 minus 2y. Right? So over here, what we're going to do, we're going to put all of 3 minus 2y down to group it with dy, and then all of dx, we're going to send it up. So it's going to be dy over 3 minus 2y equals dx. Then we're going to plant our integration. So then the integration for dx is going to be x. It's fairly simple. But the integration for dy over 3 minus 2y, this requires integration with substitution by saying let u equals 3 minus 2y and du is going to be minus 2 dy. Now, I don't have minus 2 dy, I only have dy, right? So I'm going to divide by minus 2 by minus 2. So du over negative 2, it is going to be dy. So now the integration with substitution is going to be du over negative 2 over u. Now, the invisible negative 1 over 2 can go outside of the integration. So negative 1 over 2 du over u, which is going to be ln u. And then you just replace u back to its original form. So it's going to be ln 3 minus 2y. So the integration for the first one, the left one, it is going to be ln 3 minus 2y equals x plus c. Now we need to find c, right? So I know for sure that x is equal to 2 and y is equal to 1. So it is going to be ln 3 minus 2 multiplied by 1 equals 2 plus c. Now 3 minus 2 is going to be 1, and ln 1 is equal to 0, by the way. So 0 is equal to 2 plus c. Therefore, it's going to be negative 2. C is going to be negative 2. So I'm just going to continue the solution under part D. So basically, we're going to get ln 3 minus 2y equals x negative 2, because c was equal to negative 2. But remember, they wanted us to find y equals f of x. So the solution must be y is equal to something, not ln 3 minus 2y. So over here, how do I get rid of the ln? Using e. So now e and ln are going to cross out. So we're going to get 3 minus 2y equals e to the power of x minus 2. Now just rearrange your equation. Take the negative 2y over here. Take the e to the power of x minus 2 over here. You're going to get 3 minus e to the power of x minus 2 equals 2y. Finally, divide by 2. Divide by 2. There you have it. That's it. It is kind of long, obviously. However, if you understand this step by step, it's fairly simple and fairly easy as well. Now, part D. In part D, they asked me to find limit as x is going to infinity for f of x. And this is possibly the easiest question over here. Limit as x is going to plus infinity f of x. Or maybe the question was actually minus and plus infinity. So limit as x tends to plus infinity for f of x is going to be limit as x tends to plus infinity for 3 minus e x minus 2 over 2. So you just replace x with plus infinity. So 3 minus e to the power of plus infinity over 2. And e to the power of plus infinity is plus infinity. So 3 minus infinity, because minus plus is minus over 2. So it's going to be minus infinity. Now, limit as x is going to negative infinity, f of x is going to be limit as x is going to negative infinity, 3 minus e negative infinity over 2. Now, e to the power of negative infinity is 0. So 3 minus 0 over 2, which is 3 over 2, which is 1.5. So once again, this is a DOK 3 question, and the top question is basically a DOK, I believe DOK 1. But yeah, these are 2 questions to quick review differential equations. 7.2 general solutions, verifying general solutions for differential equations, and 7.7 particular solutions of differential equations. If you have any questions, please leave a comment, like this video, and be sure to watch the other videos because they are as important as this one. Thank you so much.